I'm Steve Stadge, Chairman of the Board and Chief Technical Officer at Austin American Technology. Over the past 30 years, I've seen many firsts and had the privilege of working with both customers and suppliers to our industry on new and exciting developments. We were the first to introduce the first automated stencil cleaning system, the X30. We were the first to introduce a first solvent recycling cleaner that was non-heated to compete with degreasers. We were the first to introduce the high energy jet cleaning that are found in our inline and batch cleaners and the rest of the industry today. And we were the first to introduce displacement drying, which does not evaporate the water on the board but pushes it off the board so we have a cleaner and drier board. And I'm here today to tell you about a new and exciting first we're working on as well. One where we implement and incorporate the rose test into our cleaners. This does not require you then to go pull a board and have a sample that we would have from our cleaning operations, but rather the machine itself would automatically perform a rose test at the end of the cleaning cycle, much as we would have in our Aqua Rose batch cleaner. We also have this available in our Mega Ion cleaner, which is a solvent-based cleaner. So we're happy to have you watch our video today. Thank you very much. We look forward to being a part of your factory of the future with these new automation systems that we're putting into our cleaners.
Okay, this is a presentation on changing rose testing requirements by Steve Stadge. And this is a presentation that was given to the North Texas chapter of the SMTA in January of 2018. In our outline today, we're going to talk about what is rose testing. At the presentation, about half of the audience did not really know what rose testing was. So that is not something that's commonly known today, but most of the engineers that are involved in cleaning do know what rose testing is. We want to talk about what happened to the rose test requirement in November of last year. And before to tie that all together, we're going to talk about a cleaning process change that I had early in my history and my career, and how that relates back into this question that we're asking: what happened and why did it happen? In that story, we're going to talk about the ABCs of process change and how they apply to this situation as well. And then we're going to finally end up with why did the IPC committee recommend the change and what is the future of rose testing as we go forward. So to begin, just let's review what is rose testing. It is a quick test for ionic cleanliness of an electronic assembly. It was developed in the late 60s and early 70s, implemented in the documents MIL P2809. And that test basically was looking for ionic residue that had resulted in failures in military and space programs that they had in the 60s. The acronym itself stands for Resistance of Solvent Extract, ROSE testing. It takes about 15 minutes to perform a single rose test on an assembly in a standard rose testing machine, an ionograph or an omegameter. Some of them are only 10 minutes long in terms of the test. And it quantifies the soluble ions as sodium chloride equivalent per square centimeter or per square inch, depending on what system you're in. How is this method accomplished? In the manual method, which was the original method that was developed, a solution of isopropyl alcohol and water was mixed together, a very pure solution, measuring the resistance of it before we put it on the circuit board, and then passing it at about 100 milliliters per square inch across the circuit board and collecting it and measuring the resistance drop after that. And that test was also implemented and used on all Class 3 or high reliability products in the IPC standards, as that military standards transitioned over to IPC standards. So the steering committee talked a little bit about what happened in that meeting in November. Decided to drop the rose test from the new J Standard 001G revision, and decided to replace it with requirement calling for objective evidence of cleaning control and cleaning process qualification. So that's essentially what happened in November. Well, I'm going to move to my story for just a second. This is from a story from early in my career. Once I got out of chemical engineering school, I decided to go to work for a company called Texas Instruments. And at Texas Instruments, I was put in charge of cleaning when I arrived there. At TI, we built, one of the systems we built anyways, was a laser-guided bomb system. And we built the controls of that system, the electronics of that system. And I don't know if you remember in 1978, just to bring you back, some of you weren't even alive back then, but there was a gas shortage going on at the time. And, you know, that we had long lines, the first lines I can recall, where you had to line up and wait for gasoline. And I had a production manager over the laser-guided bomb system that came to me and said, Steve, you know, look, we're going to have to use something other than solvent because we're not sure we're going to be able to get solvents, especially those ones based on hydrocarbons, in the future. So I want you to go and change our process over to a water-based system. And oh, by the way, this production guy was a peg-legged guy. He asked me, have I ever been kicked in the butt by a peg-legged Irishman until my nose bled? And I said, no, I haven't. He goes, well, good, go get this job done, or else I'm going to do that to you, basically. And I said, well, I think I understand. So being the young engineer I was at the time, I got on an airplane, left Texas, and flew out to China Lake, California, where I met with the crew out there that was in charge of testing the products that we built. And this was a nice crew out there. There was not exactly the vacation spot of California out in the middle of the Mojave Desert, but they tested all the systems that we built, made sure they were reliable and they worked. And I asked them, what do I have to do in order to get this process change from a solvent-based system that we're using for cleaning today over to a water-based system? And they said, well, you got to go talk to the boss. So I went and talked to the boss and met with him. His name was Jim Rady. Jim was a very knowledgeable gentleman. He had worked with at NASA previously with Dr. Werner von Braun on the rocket controls and developed reliable rocket control systems that we use even today. After that, he left and went to the DOD, where he implemented the standardized soldering and training programs, including the cleaning of the circuit boards DOD-wide. I talked to Jim about what was important in obtaining this change that I needed. And he said, well, it's pretty simple, Steve. Basically, you got to follow the ABCs of process validation. And if you do that, you'll probably get your change. And I asked, well, what are those ABCs? He said, well, A, ask, why am I making this change? If you don't know why you're making the change, you're probably not going to do the right test. You're not going to get the changes and the documentation I need to make sure that you're doing it for the right reasons and that you got your testing in proper order. And B, be careful to pick the right test. If you don't pick the right test, I'm not going to approve this process change. And C, once you have properly tested this change and show me the data, tell me how you're going to control the process as you go forward. So that's basically the ABCs of process control that Jim gave me at the time. Well, I got back on an airplane and went back to Texas, and I asked our team, well, why are we changing? And, you know, I already knew that Bill, our production manager, had told me that we're going to shift from an oil-based solvent system to a water-based clean system because we might have supply problems in the future. But our reliability guy came in. He says, well, you know, if we make this change, I would like to get more reliable solder joints also. That would be really nice to make sure that we have better wetting and less voids and things like that. And the production control guy said, you know, we really want fewer touch-ups also, lower cost and more reliability, like the reliability guy said. And we all talked about what were the downsides of this changing to this process. And of course, the one downside was that if we left this water-soluble flux that we wanted to change to on the board, then it was going to be more corrosive than the RMA fluxes that we were currently using. So we had to make sure that we didn't do that. We had proper testing and controls in place to avoid that. So we went to look at what kind of test we wanted to do. Well, we definitely wanted to do some cleaning performance and soldering trials, looking at our new fluxes and our new cleaning agents that we wanted to use that were water-based. Wanted to look at the visual results at various speeds, and wanted to look at our solder defect rates, and wanted to get some idea if we were in the same ionic realm that we were with our RMA fluxes. Wanted to look at product reliability through some form of accelerated corrosion test, with and without bias, because our product got stored and then got activated, and also wanted to look with and without conformal coating. And we thought maybe some kind of SIR testing would be appropriate, and maybe some kind of solder wetting test. So we went off and ran our trials and decided that we wanted to look at the solder defect rates, the bridges, the excess solder, the insufficient solder, and we ran 100 boards of each type. And in that process, we had to decide how were we going to evaluate this. Well, at the time, we really only had two options at the time. We could look at it with our eyeball at 1x magnification, or we could look at it with some microscopes we had out in the shop and look at it under high magnification. Part location was not really important to us at the time because all of our parts were through hole and they were clenched into the leads into the hole so that parts didn't move. Now that would not be the case today with SMT, as the parts can move as they reflow. So, today I would look at something like AOI, where at the time we really only had the eyeball and the magnification, so we went with that in terms of our visual results inspection criterion and approach. In the solder wetting test, we had cross sections, wetting balance, and solder spread tests, which were all clearly defined in the military specifications that we looked at. And we decided that we would look at the cross sections, which you see in the picture here, and the wetting balance test, which was quite interesting, and looked at the various fluxes to see how much they spread that we were looking at and considering for our flux change. In terms of ionic contamination, we had already been performing ROSE testing previously, so we decided to look at ROSE testing. And at the time, ion chromatography was not even available back in the 70s when we were looking at this. So we ended up choosing the ROSE testing. And we had already been doing ROSE testing previously. We just wanted to make sure that we're in the same realm that we were with the RMA fluxes and the solvent-based cleaning process. We then looked at the accelerated aging. And we looked at accelerated aging with no power because, again, these controls sat dormant for many, many months or years in a warehouse in high temperature, high humidity, maybe some salt spray. We did have a copper mirror test that was available in the military specification at the time. But we wanted to assess what happened to the unpowered electronics. Did it corrode? Did it change over time? So we decided to look, because of our product requirements, we decided to look at the high temperature storage as our no power accelerated aging. And then in terms of accelerated aging with power, we decided we could look at surface insulation resistance with humidity at elevated temperature and temperature cycling. We went ahead and looked at that as well. Or we could look at electromigration, which was a form of surface insulation resistance where you put shunting resistors and just allow the dendrites, as you see over here at BAT1, to grow. So we decided that since we were going to be under an airplane wing, we wanted to go something cycling and we wanted to go surface insulation resistance. So we decided to go with the first and not the second in terms of our test results. So we went off and ran all these tests and collected all the data and analyzed the data and picked the flux and picked the process based on our data. And then based on that, we decided that we also needed to implement some new process controls that we currently did not have in our production facility, which was limit our cleaning time to a maximum of 4 hours because, again, with rosin fluxes, they didn't corrode as fast as the water solubles did. So we didn't want to let anything sit more than 4 hours in the shop. We wanted to perform the ROSE test every shift to make sure that we weren't allowing any escapes to get out, where we pulled a board from production and we ran a ROSE test. And then we also wanted to do test our spawn fire concentration in bath, which we found if that very much would definitely impact our cleaning results that we were getting. And we found that through our testing as well. And then, so we decided to implement these 3 tests, got on the airplane, went back out to China Lake with our proposal and our data, and lo and behold, we had success, got our process approved. We built many reliable weapon systems with this new process as we went forward. So how does that tie in to what we're talking about here today about the changes in ROSE testing? Well, obviously, it does tie in. And so what really happened at the meeting in November was the committee had been torn on this subject for many, many years. And they basically were frustrated that the ROSE testing was being, even today, more heavily relied on as a single test that was being used to control and judge the majority of the clean processes today. That and visual results were the primary things that were being looked at. And there were many other things available that we could look at. Some of them, like I mentioned in the presentation, were duly developed, like ion chromatography and some of the new cleanliness test methods that we have available to assess cleanliness. So how do you move ahead based on this then? Basically, we wanted to get, what do you mean by objective evidence of control? So what are some, what do we really mean here? And the IPC voted to recommend that the ROSE testing requirement be replaced, and that's the singular ROSE testing requirement, be replaced with the objective evidence of clean control. So what is that objective evidence of clean control? That's so nebulous. How do you pin that down a little bit tighter so we understand what we're talking about here? So what do you do if you have been doing your ROSE testing, you've already qualified your process? What does that mean to you? Well, if you're currently using a ROSE testing and your process is under control, you're good to go. You've already qualified it and you're using ROSE testing to control it. You might want to consider some other things to look at as well, but you're basically good to go. So it would require no changes to your process or your qualification as you move forward. Now, on the other hand, if you're going to qualify a new clean process or requalify an existing process, you will have to show objective evidence that you have the process both qualified and controls in place to make sure it stays operating in the intended manner that you had qualified it with. So what do you mean by objective evidence? We really need to get down to what is that elusive term, objective evidence? Well, there's a lot of things that are objective evidence, but it's basically evidence that you would have that is non-biased. It doesn't show bias one way or the other in terms of I think or it should or those kinds of things. So what are those things? Those are things like your process qualification data that you ran. If you ran SIR testing or ion chromatography, those kinds of things, that is important objective evidence that you can begin to put into your pile of objective evidence. Also, you can look at things like optical inspection data. Are parts moving? Is there extra residues there that weren't there before? You can't look under the parts, so you do need to include some production way to look under the parts, and that the best way yet that they have today in production is ROSE testing data and the visual inspection data that you get out. So you definitely would want to include ROSE testing in your objective evidence. Electrical test is important because if you're having a certain rate of electrical test and that electrical test rate drops dramatically in terms of the failure rates that you have more and more failures, probably indicates you could have a clean problem, could be a component problem, but that is objective evidence. And finally, the one that's probably least attractive in terms of objective evidence is how much field returns are you getting of product back from the field. Well, if that were to spike up, that also would indicate that you have a problem in your clean process, and that's objective evidence as well. So this is what is meant by objective evidence as we move forward and pick our package of data that we're going to now say we have our clean process under control. So what is the future of ROSE testing? It's still a valid test recognized by IPC and one you should use in your objective evidence. It, along with visual examination, is still the best process control day-to-day test we have available to control the process. And new cleaners now are available for the first time in just the last few years that now collect that data automatically, collect automatic ROSE testing data at the end of the clean process, and can collect it and store it and download it to your process control system that you might have in your factory. So that brings us to what is the cleaning controls in the factory of the future going to be? Well, in the factory of the future, the factory of today really has already begun. We have communication occurring between each step of the process, from the time that the product comes into the warehouse, is loaded on the stencil printer, the solder paste, and the placement machines. All of that data is feeding back to a factory automation system. And with those sensors that are needed, and we can control the whole process essentially from a factory automation system. The reflow oven, the inspection, the cleaning, the electrical testing, ultimately out to the customers in the field. We'll look at all this data and we'll control the process with that data. The ultimate goal being that when we have control of the process, we won't have these problems. And if we do have problems occur, they will automatically be flagged, and then we'll issue a team out to go correct the problems. So in the factory of the future, we turn the lights out is what our objective is. Now, we probably won't get there anytime soon, but in order for that to happen, we have to have this communication. We have to have ROSE data feeding back in, cleanliness data feeding back in from our cleaning process in order to allow this to happen and move our factories into the future and truly get the level of reliability and control that we need. In summary, the IPC now requires objective evidence of cleaning, which does include ROSE testing in many instances and much more. So they're actually asking for more, not less, and they're not dropping the ROSE testing requirement. They're just asking for additional information to show that you have it under control. The best way to approach this is using the ABCs that I've laid out in this presentation. Go through and ask yourself why you're making the changes. Be sure and get the right test, and then get those process controls in place.
Thank you again. You can contact us at the information provided.